Hi there, I'm Corey.
And I'm Bracken.
And this is the third instalment in the Chemistry in the Third Dimension Plastics series. So far, we have seen where plastics come from and the problems they are creating in the environment, especially in the oceans. In this video, we'll be exploring why traditional plastics are difficult to break down and what scientists are doing about it. Let's quickly remind ourselves of the ways plastic can be broken down for reuse.
They can be cleaned, ground into smaller pieces, melted, and remoulded. This can only be done 2 to 3 times before the material begins to lose its strength though. They can be superheated to break them down into CO2 and H2. Although CO2 is a greenhouse gas, in these instances it's collected and fed to algae that can produce useful products that we'll discuss later.
They can also be broken down into their original monomer units and remade into fresh plastics. However, until recently, the processes to do this have been highly inefficient and costly.
Traditional plastics made from fossil fuels were invented to be long-lasting and robust. However, these features make it incredibly difficult for natural processes to break these plastics down. In our first video on plastics, we looked at the structural formula of these plastics, and the one thing they all had in common was they had unbroken chains of carbon-to-carbon bonds.
These bonds are incredibly strong. It requires vast amount of energy to break them and to turn the polymer back into its original monomer building blocks. It's why plastics are so durable, and with currently available technology, the most cost-effective way of recycling plastic is to melt it down and remould it. But this isn't a long-term solution.
So what if we created plastics from sustainable resources that didn't have these strong carbon chains? This is what scientists are doing with bioplastics and biodegradable plastics. These terms may sound incredibly similar, but they refer to different properties of each plastic type.
Bioplastics are made from renewable resources such as seaweed, cornstarch, and vegetable oil. Biodegradable plastics can be made from both renewable resources and fossil fuels, but can be broken down using biological processes into natural products, typically water, carbon dioxide, and biomass, which is a material used for electricity or heat energy production. It is important to note that not all bioplastics are biodegradable, or biodegrade any easier than fossil fuel-derived plastics.
The most common example of a plastic that's both a bioplastic and a biodegradable plastic is polylactic acid. This polymer is made of many lactic acid molecules bonded together, but instead of an unbroken carbon chain forming the backbone like many other types of polymers, there's now an oxygen in the chain after every 2 carbon atoms. The bond between the carbon and the oxygen is much weaker, allowing the long chains to be broken down much more easily.
Creating new sustainable plastics is only one step to fixing the problem. It's been over 60 years since the mass production of plastic began. In that time, an estimated 9 billion tonnes of plastic has been produced. Of that, roughly 7 billion tonnes of it have become plastic waste in landfills and the environment. By 2050, it's predicted there will be more pieces of plastic in the ocean than fish. This is a problem that needs fixing, and fast.
Back in 2016, in the before times, scientists in Japan discovered bacteria in contaminated mud near a plastic bottling plant. It was found to produce an enzyme capable of breaking down the oil-based polymer, PET, into smaller molecules. Since then, researchers have been working to increase its effectiveness. It can now break down a piece of plastic in 10 hours at room temperature into the original monomers that are used to make PET. These monomers can then be reused to make new polymers. The monomers can be broken down even further by other bacterial enzymes to produce carbon dioxide, which can be fed to algae, and which can be sustainably turned into bioplastics, food, or even biofuels.
What is needed to make this research a reality is public support, not only for a reduction in the use of plastics, but for a change in the types of plastics we do use. With electric and hybrid vehicles that use less petrol becoming more common, the oil industry has begun to invest more heavily into plastics manufacture. Scientists are needed to research different types of plastics to understand how their molecular structures can affect their breakdown, in order to make the recycling process easier and more efficient. As a species, we need to come together to change this course of action and create a cleaner environment and more sustainable future for ourselves.
In the final part of this series on plastics, we'll show you how to make plastic at home using renewable resources.
But until then, thank you for listening. See you next time.